Here we have been asked to find the number of the chiral carbon atoms in the compound X, Y and Z respectively. Now, it is very important to understand the basic concept. The basic concept in these type of the questions says that a chiral carbon atom is an sp3 hybridized carbon atom to which four unique groups are attached. The four groups that are attached to the carbon atom have to be different. All of them have to be different. Now let us begin to analyze the first carbon compound. Here, this carbon atom, it cannot be chiral as one hydrogen atom is attached to it, one methyl group is bonded to it, and the other two carbon atoms, which are located here and here, are the same type of group as when we travel here we get one CH2 group over here and we get one CH group over here. Similarly, when we travel here, we get one CH2 group here and one CH group here. And we know that the carbon atom of a methyl group is never going to be chiral, as out of the four groups attached to it, there are going to be three hydrogen atoms. These two carbon atoms cannot be chiral carbons as they are not sp3 hybridized, they are sp2 hybridized. These two carbon atoms are also not chiral carbons as two hydrogen atoms are attached, are bonded to each of them. So we analyze compound Y. Here, what we understand is that these four carbon atoms are not going to be chiral carbons as all of these atoms have two hydrogen atoms bonded to them, and the carbon atoms of the methyl group cannot be chiral. But here what we observe is that these two carbon atoms are going to be chiral carbons as one hydrogen atom is bonded to both of them, one methyl group is bonded to each of them, and we also have this individual group that is bonded to both of the carbon atoms and this group. So essentially, when I travel in this direction, I get only one CH2 group, but when I travel along this direction, I am going to get a total of a 3 CH2 group. Hence, we can say that this atom is going to be chiral. Similarly, this carbon atom here also is going to be chiral. Thus, there are two chiral carbon atoms. Now, shifting our attention to compound Z, what I understand is that the carbon atom of the methyl group is definitely not going to be chiral in any case. These three atoms of carbon are also not going to be chiral as they have two hydrogen atoms bonded to each of the carbon atoms. These two carbon atoms are definitely not going to be chiral as they are sp2 hybridized, they are not sp3 hybridized. But what we observe is that the remaining atom of carbon, this is going to be a chiral compound as we have one methyl group bonded to it, we have one hydrogen atom attached to it, and then if we travel in this direction, we have a CH2 group located here. If we travel in this direction, we have a CH group located over here. So here we have a CH2 group, here we have a CH group. Thus, the four groups attached to the sp3 hybridized carbon are going to be all unique, and thus this is a chiral carbon atom. So in total, we have 0, 2 and 1 chiral carbons in the following compounds X, Y and Z.